Welcome to Freedom with DSA, your one-stop solution for your DSA learning. Let me introduce about myself and about my channel and who are my target audience. The purpose of this lecture is to demonstrate a clear-cut guidance about future lectures and my flow of explanation. And who want to master algorithms, build logic, and break free from data structures and algorithms, DSA. Most welcome for them, and who want to enhance their problem solving capabilities and preparing for the interviews also, this channel is useful for them. So without any delay, let me introduce myself, and my name is Varun. So I'm the founder of Freedom with DSA. Currently, right now, I'm pursuing my BTech final year computer science engineering, and this course explanation series is going to be very beginner friendly, interview focused, and practical walkthroughs. In my own words, I teach the DSA I wish someone had taught me. One clear idea at a time, no confusion, no shortcuts, just simple explanations that actually stick. I will make complex DSA concepts much more easier and simpler so that you guys can easily understand every concept in just one go. And I will give you my channel overview, unlocking better problem solving one concept at a time. And this channel is dedicated to helping you master data structures and algorithms, the key that unlock better problem solving skills, cracking coding interviews, and open doors to your dream tech careers. Who are aspiring for the top world best companies like Google, Amazon, Microsoft, DSM mastery is non-negotiable. To master DSA, our channel, your channel, that is Freedom with DSA with you. So, whether you are a student starting out, a self taught coder, or preparing for technical interviews, this channel is built to help break free from confusion, and build real confidence in DSA. So, many of you guys have DSA fear. I want to remove that fear only. The main agenda of this channel is to remove that fear and develop the intuition of algorithmic problem solving. So, what you will find here, clear beginner friendly explanation, core DSA concepts broke down from the ground up. So, ability to break down the complex concepts into understandable way is my specialty, and step-by-step problem solving walkthroughs. Watch the thinking process, not just the final code. Final code is the last step which you see on the screen, but the internal logic building is what more important. Watching your thought process step by step, running the core logic is very important. So interview preparation and coding patterns, the recurring techniques that show up again and again. If you see in the lead code only, you have close to 4,000 problems. Doing all those 4,000 problems are not possible, but mastering patterns is possible. So there are set of 20 to 25 patterns, algorithmic patterns, and we have few set of data structures, and if you master them, then you can solve any number of DSA problems you want at any level, easy, medium, hard. The level of difficulty doesn't matter at that point of time. So practice problems, digestible breakdown, so no overwhelm, just one clear step after another. So no confusion, just one step after the another, clear cuts, we will go step by step manner. So our mission is to make DSA simple, practical, and something that actually enjoy learning. DSA is all about visualizing the concepts and ability to break down the complex things into much more manageable parts. So I will do that in later further videos, upcoming lectures, and how I teach breakdown, naive, better, and optimal. So my problem solving approach, I developed a framework, a four-stage framework. So every walkthrough I make follow the same four-stage framework only. So uh, break down the problem, understand exactly what being asked before writing a single line of code. So ability to understanding and interpreting the problem statement, given problem statement is very important, and developing a basic intuition or a basic approach around the problem is what the naive approach is. So solve the first simplest way that comes to your mind, and correctness first. So this building a basic intuition around the problem is what the naive approach says, and building the better version of the naive approach is the better approach. Means we are spotting the wasted work, spot the wasted work, remove it with a smarter technique. Means whatever the unnecessary thing is going happening in the naive approach, we will remove it in the better approach. Whereas in the optimal approach, push down for the best possible time and space complexity. In the optimal approach, we have less time complexity and without any extra space if possible. So why this order only? Jumping straight to the clever solution skips understanding that makes it stick. I walk through all four stages because that would build the reasoning skill that transfers to problems you will never see before, not just memorized answers. If you directly jump to the optimized solution, you will never get the feel of that approach. When you go from the basic intuition to the optimized approach, you will get the real value and real understanding of the optimized solution, why we are doing in this manner only, why some solutions are failing, some solutions are successful, some approaches are successful. So ability to pick the right data structure, right algorithm in the right time under pressure is very, very important. So I will help you in that dimension as well. So ability to break down the problem, so understand before you solve. Okay, restate it simply, say the problem back in plain English. If you can't, you don't understand it yet. So if you read the problem statement, make a storytelling in your head and reformulate in your own head in your own words, so that you can easily develop a solution and more efficient solution very easily. Identify inputs and outputs, what exactly comes in and what exactly comes out, what is the input is what is the given input and what is the expected output. You need to have this clear cut difference. This will allow you to build logic accordingly. So spot the constraints, so data size, value ranges, edge cases, that shapes which approach will even work. Edge cases is nothing but hidden scenarios. You need to think about the hidden scenarios also in DSA. Okay, question your assumptions. Reasoning based assumptions are very important while you're building a logic. So why you are assuming in this manner only, you need to have a reason also. So what are assuming isn't actually guaranteed. If you make wrong assumptions, you may lead to wrong results, you will not get the expected output. If you make the right assumptions, you will go to the right solutions, you will get the expected output, as simple as it is. So why this matter? Most wasted effort doesn't come from the writing bad code, it comes from saving the wrong version of the problem. A few minutes here save a rewrite later. If you follow these steps, like restate it simply, identify input output, spot the constraints, question your assumptions, this allows you to build solutions very, very easily. So this is the process we need to break down the problem in this manner. Okay, so in the step 2, naive approach or the brute force approach. So use the first idea that works. Usually the synonym of the naive approach is the brute force. Check every possibility, no shortcuts yet. Prioritize correctness. A slow correct solution beats the fast wrong one every time. So we need to build a basic intuition around the problem, which is what the naive approach says. So in this naive approach, you can expect a higher time complexity. Nested loops, repeated scans are common that are expected here. In the naive approach, you can observe the quadratic time complexity big O of n square and the cubic time complexity sometimes also big O of n cube. This is the worst case time complexity. The running time complexity, the running algorithm time complexity is too long, so we need to reduce that only. So use it as a baseline. Once it works, you have something correct to compare every later idea against. Once you build the naive approach, you can, on top of it, you build the better versions of the naive approach, and where you can relatively compare each and approach to the naive approach only, and how it is efficient, how much is efficient, and what changes makes it more efficient. So these kind of things you can observe when you have a naive approach as a baseline. Okay, so why this matters? The naive approach isn't a step to skip, it's how you actually learn what's slow about the problem, which is exactly what the next step fixes. Okay, so once you build the basic intuition, now it's time to move to the better approach. Okay, so this better approach is a brute force or smarter technique. Means there are unnecessary computations and extra space is taken in the brute force. You need to identify the extra computations, what is going on, and we need to remove that extra computations. If you have taken any extra space also, you need to remove that extra space using some smart techniques. So find the wasted work. Okay, where is the naive approach? Recalculating something is already new, some kind of unnecessary computations. You need to question yourself in this way. So reach for a better tool. Sorting, hashing, two pointers. These are the tools and techniques available to you. So pick the right one and apply it. So whatever the technique removes that waste. Cut the time complexity. So a meaningful step down, still simple enough to explain in one sentence. So here it is very important, keep it understandable. Why? Because it's a bridge gap. So not yet the cleverest solution, just a clear better one. The better approach is like acts like a bridge between the naive approach and the optimized approach. Between the naive approach and the optimized approach, the bridge, the intermediate approach is your better approach. Okay. So it is not too worst or the best. It is just like intermediate. So why this matters? This is where the most real interview answers land. It shows you can improve on the first idea, which matters as much as reach the perfect answer. That means here is the real understanding will come up, because when you targeting from the naive approach to the better approach, you use your mindset and improve the efficiency of the algorithm. And also from the better approach, if you want to reach to the optimized approach, you need to improve much more better. So in the process you are improving the efficiency of the algorithm. That means you are improving your thought process, and by identifying the unnecessary computations, and you by reducing the extra space as well. So this is what the interviewers are expecting. So ability to demonstrate the journey of efficiency of the solution from the naive approach to the optimized approach is very very important. Once the better approach, if you achieve the better approach, the next step is optimal approach. So in the optimal approach, the version is we are building toward along all along. Okay. So push the complexity down further. Often a single pass, the clever invariant or the right data structure means we are achieving the desired time complexity with a no extra space if possible, and accept the trade-offs. Optimal can be harder to read. That exactly why we build up to in all stages. So we are build up to it in stages because here the naive approach, better approach, optimal approach. This is the step-by-step framework we follow to achieve the best possible outcome with the desired less time complexity. So this is what interviews want actually. Not because it's clever, but because you showed the reasoning that got you there. I hope you understand. Because finally, the reason to achieve the optimized solution is the naive approach and the better approach. Why you achieve the better approach? The naive approach is the worst. Why you achieve your optimized approach? Because the better approach have some flaws in better approach also. So why this matters? An optimal solution you can explain beats one you memorized. When you explain only optimized solution, the interviews may think you mug up. But if you explain this journey of efficiency of improving the algorithm, the way how you improve the efficiency of the algorithm from the naive to the optimized, that shows your mindset of your DSA. Okay. So reaching it through all four stages is what makes it actually yours. Okay. So now I want to give you an analogy about the channel. So some of you may think this is not a two-wheeler. Imagine this is a two-wheeler. Okay. So why ride? Why only two-wheeler? You may think. I will map to it to our channel. I'm not going out of. So how DSL learning works? This is a real analogy I taken. So riding a two-wheeler, learning DSA. The biggest question is why? Why riding a two-wheeler only? Okay. Balance balance act as a core logic. Vehicle acts like a language. Road like a problem. Problem gives you the roadmap. Vehicle gives you the. We have different brands of vehicle. We have different brands of languages. Python, Java. Similarly, balance is like a core logic building experience. Logic remains same, execution varies, and the problem will acts like a torch barrier as a roadmap to achieve the solution. So here you can observe balance is constant. Core logic building experience also constant, which remains same. uh, Changes with the vehicle, programming language also changes as per the requirement. Syntax changes, balance stays with you. Here is the final recap, the key takeaways. What to remember before your next problem. Break it down before you solve it. Inputs, outputs, and constraints come first always. Naive isn't wasted, it's how you learn what's slow. A correct baseline beats a clever guess. Next, better comes from removing repeated work. Most real progress happens at this stage. Optimal only counts if you can explain it. The reasoning is the part that transfers to new problems. Balance is constant, execution varies. Core logic carries across every language you will ever use. So, in short, we will discuss all the approaches for the given problem statement, from the naive approach to the optimized approach. In each and every approach, we will interpret and understand the given problem statement, developing core logic building intuition, and demonstrating the code execution using Java programming language. And in the fourth part, ability to analyze and understand the time and space complexity. And the fifth one, we will relatively compare with the previous approaches and analyze why the one approach is not good and another approach is efficient as well. So we will take the reasons behind that as well. So this is the final key takeaways we can get from this slide. And finally, hit subscribe and start your journey to coding freedom, one concept at a time. If you like my video, please like, comment, share, and subscribe to my channel. Thank you. Have a nice day.